Welcome to Filtration Options in the Power Generation Marketplace. So when we think about water filtration in a power generation facility, what probably comes to mind is the fact that there is a lot of water being used every minute in a power generation facility, almost regardless of what style of plant, but certainly huge water users such as traditional coal-fired plants, combined cycle plants, nuclear facilities use the most water, and then probably tail off as you get down to something as simple as a combustion turbine peaking plant. But nonetheless, these facilities use a lot of water, and they use a lot of water of varying water qualities. If you think about some of the applications, you've got the pretreatment section, taking water from a surface body of water, such as a river or a lake, or perhaps water is being brought in by well. That water needs to be treated, screened, in some cases clarified. From there it splits into the various applications, whether it be service water, cooling water, boiler water makeup. Again, each one of these requiring a different amount of filtration. In some plants, let's talk about, again, traditional coal-fired, you might be looking at things such as flue gas desulfurization, ash handling, coal pile runoff. In a combined cycle and a gas turbine facility, you could be looking at air inlet fogging or cooling, which will require a pretty high quality of water, akin to boiler feed water. And then in some facilities you might even have a wastewater disposal system that will use different types of filtration. So when you're going to spec out a filtration mechanism or system in your power generation facility, there's really a handful of key things you really need to consider right up front. Those would be the quality of the water that's coming into your filtration process. Second would be, how pure do you need it when it comes out the end of your process? So process inlet and outlet need to be considered. Flow rates, footprints. You can get some filtration systems that require a very, very large filtration system. Let's talk about a traditional gravity sand filter as an example. Or you can get some things that are pretty small. A packaged reverse osmosis or ultrafiltration system can be squeezed down to a pretty small footprint. And of course, you're always going to want to look at overall capital cost and then long-term operating cost. So, filtration. There's really two major categories, granular and membrane. Now your granular filtration is kind of the old school style. We're talking about sand, anthracite, maybe garnet, activated carbon, things of that nature. Those can either be gravity fed or could be pressure filters depending upon the application and the requirements that you're looking at. These are pretty good filters and serve the industry very, very well for hundreds of years. But if you're really looking at maximizing the purity of the water leaving your filtration process, you're probably going to be moving into one of the more modern technologies, one of the membrane filtration technologies, such as microfiltration, ultrafiltration, or nanofiltration. At the upper end of that membrane technology resides reverse osmosis. And by the time you reach reverse osmosis, you're almost leaving the spectrum of true filtration because you're moving into something that can actually separate at the molecular level and is really a demineralization process, although it's usually lumped into filtration. That's why we have it listed here. Now on slide 8 of the slidecast, and again if you're simply listening to this, I encourage you to go download the slide presentation so you can see this chart. But on slide 8 we have a filtration operation comparison guide that shows the filtration capabilities in terms of how small of a particle can be removed by the various types of filtration mediums, going all the way from a coarse sand all the way through reverse osmosis. When you look at this chart, a couple things will become apparent, and that is, one, that reverse osmosis is by far the most efficient filtration mechanism, and two, that most of the filtration mediums overlap in terms of efficiency on some pretty broad levels. So when you're looking at what filter mechanism to choose and what style of filter, you really need to look at all of the other parameters we mentioned in regards to what size footprint do you have available to you, capital cost, operating cost, inlet water quality variations and things like that, because that's really going to drive your decision as to which way you turn. So if you think about kind of old school granular filtration, that operates on the principle of what is known as dead end water filtration. And in dead end water filtration, you are passing a liquid, in this case water, through a filter media, and what's coming out the other side of that filter is the filtered water. What is remaining in the filter medium is the dirt, particulate, and contaminant. Now that is in contrast to something such as ultrafiltration or reverse osmosis, where in most cases you're using what is known as a cross-flow water filtration mechanism, where the water that is being treated or filtered is going alongside a filtration mechanism or filtration medium, and the clean water or the permeate is passing through the wall of the membrane and being separated into actually three different streams. You have your inlet water stream, you have your reject water stream, okay, which has the concentrated impurities in it, and then you have your clean water stream, which is the filtered water, the permeate, other terms used to describe that. So again, basic difference: in your classic dead end filtration, you have an inlet stream and an outlet stream. That's it. In a cross-flow filtration system, you have an inlet water feed, you have a reject water feed, and you have a filtered water or permeate feed. So we're just touching the basics here. What I urge you to do next is download the complete white paper entitled Understanding Water Filtration Options in the Electric Power Generation Industry. It's about an 11-page paper filled with tables, charts that will allow you to make a very informed decision as to which one of these various styles, or perhaps combination of these different styles and options of filtration, make the most sense for your particular application. So again, the title of the white paper is Understanding Water Filtration Options in the Electric Power Generation Industry. So why choose Lane for your power generation water filtration application? Pretty simple. We bring total water expertise from source to discharge, from all of the filtration options we just discussed to hydrology and the ability to locate, test, blend, and determine what is the best water source for your particular application. Then well drilling, actually going out and sinking the wells that will feed your facility, whether it be a new facility or you're looking to retrofit a water source. Pipeline construction, whether the well is on site or whether it's say 10 miles away, Lane's construction arm can bring that water to the fence and then bring it into the fence and have your facility running on a new water source.